Okay. Once again, good afternoon, guys. I uploaded some problems that I worked on last class. The muscle mass problem, New York to Elucim problem, two numbers practice problems, Gary, Bill, Carmela. So you want to practice some of these, okay? In class, we used to do some of these in class, right? Since we are doing it online, we are not doing these problems in class. So you want to practice them, okay? Again, this folder is very important. All the difficult problems that I think you need to practice, they appear here. All right. What are we? One more thing. One more thing. If you go to your assignment packet, you will see I have uploaded two more sections. I've uploaded 8.1 and 8.2. By the end of today's lesson or after the end of today's lesson, you should be able to do most of the problems from 8.1. 8.2, we'll do it probably next week, quite likely. Again, if you have any questions from MATLAB that we have done in the past, you can email me, you can ask me here, no problem. So let's go ahead and work on some of these problems. From 8.1 and 8.2, I have assigned 1, 4 through 11, and 14. So let's work on number 1. So we're going to be doing algebra. Okay, this algebra is a little different from the kind of algebra you did in college. Don't worry about it. Okay, so let's work on this one. Number 1 from 8.1a. Okay, there's not a lot of lecture, even though this is a new chapter. I'm just jumping into the problems, and I don't think you'll have any trouble. Um, there's not much to say. You guys know what variables are. We're going to be writing equations, writing expressions. That's the goal of this chapter. So we'll try to do things like the way middle school students are supposed to be taught. I know you guys are early childhood majors, but it's a part of the syllabus. So it's algebra, but not college algebra. So it's a little more um, aligned with what you guys will be teaching. So this is 8.1, number 1. Okay. Translate the following phrases into algebraic expression. All right, and you're going to see some of the things we did in chapter 1, patterns, arithmetic sequence, they'll come back here again. Even the first one is about arithmetic sequence. The fourth term of an arithmetic sequence whose first term is 10 and the common difference is D. Remember that formula, nth term of an arithmetic sequence formula? The nth term, first term, plus n minus 1 times common difference. We're working on A. So based on this formula, they're saying the fourth term, you have to write the fourth term. The fourth term is clearly the first term, which is 10, they're telling you. And n minus 1 is going to be 3 because n is 4. And d is going to be d. So this is what they're looking for in part A. They want you to find the fourth term if the first term is 10 and the common difference is d. Where's this 3 coming from? Well, if they want you to find the fourth term, 4 minus 1 is 3. That's part A. Okay. 15 less than twice a number. Let the number be n. Let the number be n. You can you can call it anything you want. You can call it A if you want to. I'm just going to stick to n. Okay. 15 less than twice the number. Well, multiply the number by 2 and then subtract 15. 15 less than twice the number. That's your part B. Part C, 15 times the square of a number, okay? So 15 times the square of a number. Excuse me, guys. It covers my writing. That's your part C. Let me bring this here. I need the room. B is that, and C is this. The difference between the square of a number and twice the number. Okay. The square of a number is n squared if the number is n. And difference means subtract, and 15 twice the number 2n. That's your D. I'm going to pause it just a little bit, okay? To make sure you guys don't have any questions. So that's all of problem number 1. Okay, guys, let's look at the next one. I think the next one is number 4. Okay, it's a long problem, and we're going to do it very patiently. Be a little, and we have to be a little careful. Okay, let's see. The cost, part A, the cost of having a plumber spend 8 hours at your house if the plumber charges $50 per coming and $60 per hour. So no matter how many hours the plumber works for, you're going to pay them $60. And if they work for 1 hour, sorry, you're going to pay them $50 fixed. If they work for 1 hour, you'll pay them $60 more. If they work for 2 hours, you'll pay them 2 times $60. They work for 3 hours, you'll pay them 3 times $60. So how do we do that? We can do it like this. Okay. Suppose the plumber is spending 8 hours. So he's gonna get his $50 no matter what, plus 60H. And the whole thing is a dollar amount. That's your answer to part A. Okay, B is a little tricky, guys. The amount of money in cents in a jar containing D dimes. Okay, I'm gonna make a table here, guys. That's gonna help. So okay, this is the number of dimes. Okay, dimes. So number of dimes. Number of dimes. I don't think I need this column. Okay, number of dimes. The question says amount of money in a jar containing D dimes. Okay, that's D. That's easy. Okay, some nickels and some quarters. If there are three times as many nickels as dimes, that means number of nickels. Nickels will be 3 times D. Okay, I'm not even answering the main question yet. I'm just listing. If the number of dimes is D, the number of nickels, which is 3 times, is nickels. The number of nickels is 3 times the number of dimes. So it has to be 3 times D. And then quarters, 3 times as many quarters as nickels. So whatever the number of nickels is, 3 times that is going to be the number of quarters. So the number of quarters is going to be 3 times 3D. And it turns out to be 9D. Okay. It's not very clear here, but that's really what they mean. Now, this is all fine. I'm going to save it here. I'm going to work on my main problem. Now, if you have D dimes, they want you to write an expression that represents the total number of cents you have in the jar. You have D as in dog, D dimes. That's going to be 10 times D cents because each dime is worth 10 cents. And how many nickels do you have? And each nickel is worth 5 cents. So you're going to multiply 5 by 3D. Then each quarter is worth 25 cents. You're going to multiply 25 by 9D. You're almost done. You can simplify it further. You probably can do something like this. You can say 10D is 10D. 3 times 5 is 15D. And 25 times 9 is 225D. And if you add it all up to 25 plus 10 plus 15 is 25, 250D. And that's your answer to part D. Part D is a little tricky, guys. You want to make sure you understand. I'm going to pause here a good 1 minute for part D to sink in. Part B, I'm sorry, guys. Part B. Okay. I'm going to delete these texts. All right. Part C is sum of three consecutive integers. Okay, what are integers, guys? Integers are numbers like 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4. So if you look at them, they go up by 1. 1, then 2, then 3, then 4, 0, 1, 2, 3, 4. Integers are these numbers, the ones that I just described, and they go up by 1. They want you to find the expression that represents the sum of three consecutive integers if the least one is x. That's not that bad. C. The smallest one is x. The next one is x plus 1. And the next one is x plus 2. And we're almost done, except for we can simplify it further, and we should. I have 3x. 1 plus 2 is 3. That's your answer to part C. Sum of three consecutive integers if the least is x. If the smallest one is x, the next one is x plus 1, the next one is x plus 2, and the algebra tells you to write it in this manner. Okay, guys, part D is a little tricky, and I need a little extra room, so I'm going to get rid of this. Part D says the number of bacteria after n minutes if the initial amount is Q and the number of bacteria doubles every minute. So I'm going to make a table for this. So if you have a difficult problem, it doesn't hurt to organize your thinking by making a nice table. Okay, let me do it again. Okay, this is time, and this is the amount of bacteria. I'm just going to write amount. Okay, your time starts with zero. Okay, if you don't start with zero, then you'll mess up the problem. Okay, your when the clock starts, you have Q bacteria, Q bacteria. Okay, and every minute it doubles. After 1 minute, you will have 2 times Q bacteria. After another minute, which is 2 minutes, you will have this 2 times another 2 because it doubles 4Q bacteria. Another 1 minute, which is 3. After 3 minutes, you will have 8Q bacteria. After 4, you will have 16Q bacteria. Now, it's okay. This does look like a pattern. You have a bunch of even numbers. Okay. 1, 2, 4, 6, 7, 8. 8 times 2, 16, they're all even, but that's not good enough. All the even numbers aren't here. 10 is not here. 6 is not here. So what's going on, guys? Now take a look, guys. I'm going to leave the first two alone. For the next one, I can write, instead of 4, I can write 2 times 2Q. And this is equal to this. So instead of 4Q, I can write that. It's the same. Instead of 8Q, I can write 2 to the power 3 because 2 times 2 times 2 is 8. Instead of 16Q, I can write 4. So do you see any patterns now, guys? I see something is going on. And this is 2 to the power 1, and this is 2 to the power 0. So this 2 goes here. This 3 goes here. This 4 goes here. And this 1 goes here. And 0, well, is that inconsistent? Not really. 2 to the power 0 is 1. 1 times Q is Q. So even that works for the first one. So I'm going to get rid of this. Now they're saying after n minutes, after 2 minutes, it's 2 to the power 2 Q. After 3 minutes, it's 2 to the power 3 Q. After 4 minutes, it's 2 to the power 4 Q. So my answer will be 2 to the power n after n minutes times Q. That's your answer to part D. Okay, I'm going to pause there just a little bit. I mean, not just a little bit. I'll be happy to pause for a minute easily. You do want to draw this table. If you don't, you're going to see your number will be a little off. If you really see it well, you might be able to get by with it. So we are going to move on. Let me get rid of this. We're doing E, the temperature after T hours, if the initial temperature is 40 degrees and each hour it drops by 3 degrees. So your original temperature is 40 degrees. You write 40. It drops 3 degrees per minute, per hour, and you have T hours. So it's going to be 3 times T. Done. And the whole thing is in degree. This whole thing is in degree. Degree Fahrenheit. I'm not going to worry about the unit. Again, you start with 40. Every hour, you lose 3 degrees. So in T hours, you're going to lose 3 times T degrees. You subtract and you're good to go. Okay. The next one, F, Powell's total earnings after 3 years, if the first year his salary was S dollars, the second year it was $5,000 higher. Okay, let's write it down. First year salary, second year salary, and what's third year salary? He made twice as much as the second year. So whatever he made the second year, which is S plus 5,000, he made twice that. All you have to do is do a little algebra. Okay, so this is 2S, that's 210. So I distribute 2 over, I get 2S times 10,000. And then I add all the S's, add all the numbers, and this is going to be 4S, and this is going to be 15,000. And this whole thing is a dollar amount. This is your answer, 4S plus 15,000. This many dollars. The sum of his salary for the last 3 years. I'm going to pause here just a little bit, okay? About a minute or so. Feel free to unmute yourself. If you have any questions, if you feel like I made a mistake, let me know. Don't be shy. Okay, guys, the next one. I'm going to get rid of this. I need the room. G, the sum of 3 consecutive odd natural numbers. Guys, natural numbers are 1, 2, 3, 4. Odd natural numbers are 1, 3, 5, 7, 9. These are odd natural numbers. So the difference between 2 consecutive odd natural numbers is 2. Odd natural numbers go up by 2. That's helpful. If the least, so you for G, your least number is X. The next one is X plus not 1, but 2. And the next odd integer natural number is X plus 4. And all you have to do now is simplify. I'm going to do it right here. X plus X plus X is 3X, 4 plus 2 is 6, and your answer is 3X plus 6. Okay. The next one, the sum of the three consecutive natural numbers. These are not consecutive odd natural numbers. They're just consecutive natural numbers. And they go up by one, just like integers. Middle one is m. This time they're giving you the middle one, h. The one previous to that has to be m minus 1. And the one after that has to be m plus 1. M plus 1 done. Except for I have to do a little bit of algebra. The plus 1 and the minus 1, they will cancel each other. M plus M plus M is 3M. That's your answer. So we did this long, tedious problem, and there are some hard ones here. I think B is considered hard. Then the bacteria problem is considered hard. And some people will find Powell's one a little challenging too. I'm going to give you a minute to process and ask questions. Okay, guys, let's see what's coming up. Number 5. I don't think this is a hard problem. Okay, in a college, there are P professors and S students. There are 45 times as many students as professors. That means the number of students is much larger, 45 times large as the number of professors. So how can you write an equation that involves S and P? So the number of students is equal to 45 times P. Now, do not write it the other way around. Don't write P. That would be completely incorrect. P is equal to 45S. That would be wrong. Okay, don't do that. It's a common mistake people make. Ask yourself, which is larger, the number of professors or the number of students? Clearly, the number of students. To take the number of professors multiplied by 45, you'll get the number of students. It's a pretty straightforward problem, but it's a mistake. The problem is straightforward, but when people are reading it quickly, when they read it quickly, they mess up. Okay, let's move to the next one. This one is very similar to the one we just did. Suppose the class has G girls and B boys. There are 5 more girls. Look, the number of girls is larger. Okay, there are 5 more girls. And it's not 5 times as many girls, it's 5 more. Okay, so if the number of boys is 7, the number of girls will be 7 plus 5 or 12. If the number of boys is 15, the number of girls will be 15 plus 5, 20. So you really want to read the sentence and make sure you really understand the English term and how it translates into math. So write an algebraic equation. So I'm going to say the number of girls, which is G, is the number of boys plus 5 and not the other way around. Don't write B is equal to G plus 5. That's your answer. All right. Okay, this is a good problem, okay? I'm going to do it very slowly. So guys, The computer is telling me they will kick me out like in 5, 6 minutes. So why don't we? We are not done for the day. Why don't we quickly get out of this session and rejoin again? And I will do the same. See you soon. I'll jump out and jump in.